Hello class, and welcome to our video lesson on motion. Before we get into this video, I want you to think about a question here. How do you know an object's motion has changed? We know an object's motion has changed when it changes its position. That is how we often will know an object has changed if it's moved from one location to another. That is what we refer to as motion. There are many different ways for us to describe the motion of objects. These are just a few examples here on this slide. First of all, cheetahs can bolt at an amazing 60 miles per hour. The SR-71 Blackbird jet can cruise at a speed of 2,540 miles per hour. These are words that we often use to describe motion. In this video, we're going to explore these different words and how we use those to describe motion. We will also look at how to mathematically describe motion and how to graphically describe motion. Let us first take a look at these two words, distance and displacement. They are often confused and often sometimes people think that they mean the same thing, but they are different. Distance is the length of the route that you will travel to get to a location. Displacement is the distance between the starting and ending points and the direction in which you travel. Let's look at a picture. The distance you can see is the total route that you took and the total distance that it took you to get to that particular point. Your displacement, however, is the distance between your starting point and your ending point, and it also would indicate your direction. Let's look at another example. If a man moves from point A to point B to C, and finally to D, as shown in the opposite diagram, find the distance and displacement traveled by the man. Well, first of all, if we look at this diagram, we can see that the red arrows represent the distance that he traveled, which was 50 meters plus 30 meters plus another 50 meters, which will give you a total distance of 130 meters. However, his displacement is just the distance between his starting point, which was A, and his ending point, which was D, which here on this diagram would be 30 meters, and then including a direction would be to the north. So that shows us the difference between distance and displacement. Speed is another way that we can describe motion. And speed is something that we're familiar with, and you hear people often talk about the speed of an object. Well, the distance an object travels in a unit of time is what we call speed. And there's two ways we can describe speed. Speed can either be average or it can be instantaneous. Average speed is found by dividing the total distance traveled by the total time taken, which is a formula that we're going to look at in just a minute that we can use to calculate average speed. Instantaneous speed is the speed of an object at one instant in time. This would be the speed that we get from our speedometers in our cars. It gives us our instantaneous speed, which is our speed at that one moment or one instant in time. This is the formula that we use for calculating speed, and this is average speed, because this would be the total distance traveled divided by the total time that it took, and that would give us our average speed. So let's look at our formula for that. It is speed equals distance divided by the time. Let's try a practice problem. What is the speed of an object that travels a distance of 20 meters in 5 seconds? Well, we would simply divide the distance traveled, which is 20 meters, divided by the time it took, 5 seconds, divide those numbers, and we would get 4 meters per second would be our average speed for this particular object. By using this formula, you could rearrange these variables and also solve for distance and time. But this is the formula that we would use for calculating speed. Velocity is another word that we can use to describe the motion of an object. Velocity is actually the speed of an object and its direction of motion. Velocity will change if the speed changes, the direction changes, or they both change. An example of how you would state the velocity of an object would be the car was traveling 80 meters per second south. So when you give the speed and the direction, that is what we refer to as the velocity of an object. The speeds of these cars may be similar, but the velocities of the cars can differ because the cars are going in different directions. Acceleration. Now, acceleration is very closely related to velocity because when velocity changes, then that is what we call acceleration. There is a mathematical way to figure out acceleration, and we're going to get to that on the next slide or a few slides down. But let's talk about what does it mean when an object does accelerate. There's 3 different ways that an object can accelerate. They can be speeding up, slowing down, which is also referred to as deceleration, or changing direction. Those are the ways that an object can accelerate or change its velocity. Acceleration can be described as being positive, negative, or zero. Let's look at what positive acceleration means. Acceleration is positive, first of all, if the object is speeding up, and the acceleration will be in the same direction as the motion, which you can see here in this picture. The acceleration will be in the same direction of the motion. Acceleration can also be negative. It's negative when the object slows down, which is also referred to as deceleration, and the acceleration is in the direction opposite to the motion. So think about if you were stopping or slowing down, then your acceleration is going to be opposite of the motion of the object. An object's acceleration can also be zero. If the velocity or the speed is constant, there's no change in the speed or the direction, then you would say the object has zero acceleration. So acceleration can be positive if an object is speeding up, it can be negative if an object is slowing down, and then it's zero if there's no change in the speed or the direction. Acceleration can also be expressed mathematically. This is the formula that we use to calculate acceleration. And in order to calculate acceleration, you would need to have three variables. You would have to have a final velocity, an initial velocity, and the time that it took. If you have these three components, then you can calculate acceleration. Let's look at an example. A skater goes from a standstill to a speed of 6.7 meters per second in 12 seconds. What is the acceleration of the skater? So the first thing you want to do is identify the variables that you know. You know that your time, of course, is 12 seconds. You know that he went from a standstill to a speed of 6.7 meters per second. So the 6.7 meters per second would be his final velocity or his final speed. The fact that he started from a standstill would mean that the initial velocity or the initial speed would be 0 meters per second. Anytime you're reading a question and it says something like something starts from rest or standstill, that would mean that your initial velocity is going to be 0 meters per second. So now that you've identified those variables, let's plug them into the formula. So we know that, let's write something down here. We know that the initial velocity was 0 meters per second. We know that the final velocity was 6.7 meters per second. And we know that the time it took was 12 seconds. All right. So we've identified these variables. Now we're going to plug them into our equation, which is here. A equals your final velocity minus your initial velocity. So that would be 6.7 meters per second minus 0 meters per second divided by 12 seconds. So you do the math here, subtract these two numbers, and then you divide these two numbers. Your final answer would be 0.56 meters per second squared. Meters per second squared is the unit that we use to express acceleration. Now, let's switch gears here because we've talked about different words that we use to describe motion. We have also looked at how you can mathematically express motion. Now let's look how you can express motion looking at motion graphs. There's two different types of graphs that we're going to look at in our lesson right now. The first one is which we would call a distance time graph. And you already have a picture of this on your graphic organizer. You do need to add these bullet point notes because it tells you information about what these different lines mean on this different type of graph. First of all, a distance time graph tells us how far an object has moved with time, okay? Hence, you've got distance on your vertical axis and then time on your horizontal axis. Let's look at what some of these lines mean when they're shaped in different ways. The steeper the graph or the steeper the line, the faster the motion. So right here, you have a very steep line. So that means you will have a very fast, steady speed, or the object will have a very fast and steady speed. A horizontal line, of course, would mean that your object is not changing its position, so it's not moving, it would be at rest. This would mean that your distance is constant for a certain amount of time. If the line is sloping downward on a distance time graph, then that means the object is returning to start. A speed time graph is another way that we can graphically show motion. A speed time graph will show us how the speed of a moving object changes with time. They are different. because speed and distance are different. So when we're looking at these graphs, we got to make sure that we identify what variables are shown on our axis so we can know what kind of graph we're looking at, because the lines mean some different things. First of all, on a speed time graph, the steeper the graph, the greater the acceleration. So that means that the object is speeding up um, or slowing down with a greater acceleration if you have a steep line. So like for example, we have here, this line is steep here, this line is steep. So this would mean that you have a greater acceleration there. A horizontal line means that the object is moving at a constant speed. We got to make sure that we don't confuse this with distance time graph, because on a distance time graph, the horizontal line means the object has stopped. But on a speed time graph, it just simply means that the object is moving at a constant speed for a certain length of time. And of course, a downward sloping line would also mean that the object is slowing down. So sloping upward, we're speeding up. Sloping downward, we're slowing down. And then a horizontal line would mean that the object is moving at a constant speed. Let's just look at a practice graph here. Um, this particular graph, this is a speed time graph, and it says describe the acceleration of each object. So we've got 3 different objects on here, and they're indicated by these numbers. So let's look to see how these lines are sloping on this particular graph so we can determine how how we would describe the object of the acceleration of these objects, excuse me. First of all, let's look at object 1. We can see that this line is sloping upward, so this would mean that this object has positive acceleration because it's speeding up. Number 2, the line is horizontal, so this would mean that this is a constant speed, and if there's a constant speed, then there's no acceleration because it's not speeding up, slowing down, or changing direction. Number 3 would also be constant speed, zero acceleration as well. And then object number 4 is going to be slowing down, which means you would have a negative acceleration, which is also referred to as deceleration. Let's look at an example of a distance time graph, okay? It says 3 students ran 100 meters. Which student had the highest speed? Well, we could determine that by whoever's line is the steepest. And if you look here, it would be Albert. They all ran 100 meters, but Albert finished it in the shortest amount of time, and his line is also steeper on the graph. So you would say Albert had the highest speed. What happened to Charlie's motion between 8 and 13 seconds? Well, let's look. This is Charlie's line, and you can see right here from 8 to 13 seconds, the line is flat. It's a horizontal line. Well, on a distance time graph, remember that means that an object has stopped. It's not moving, or it's at rest. So for a few seconds, or about 5 seconds to be exact, we can see that Charlie has actually stopped, maybe to take a break or something, before he started back running again. So you can kind of see an example here of a distance time versus a speed time graph, how they both show motion, but they mean some different things depending on how the line is sloping. We have now reached the end of our video lesson on motion. Please check your graphic organizer and make sure that you have recorded all of the notes that you need.